Okay, so I just had a quick look at the question that you sent me about, and for us to understand how to solve that question, we first need to understand its foundational question. So its foundational question is the sin x, is the sin x problem. So for example, if we're given a problem that states develop a MATLAB program that uses for loop constructs to implement a Taylor series expansion for the evaluation of sin x, not the problem that you sent me. Let's say it said that for the evaluation of sin x. So once we have that in mind, the next thing we need to know is that the Taylor series expansion of sin x sums up to sums up to this basically. So all you need to know is this. Even in an exam, you need to, in a way, swatila this. Yeah, I don't know how you're going to do it, but you need to know this. So after you know the summation of the Taylor series expansion of sin x, the next thing that you need is to start coming up with a design. And for that, what we're going to do is, okay, let's start design. Basically, the first thing that we're going to see from this is that it has a upper limit. So we'll need the user to insert the upper limit in this summation, in this sin x summation. So in our design, we'll say user enter upper limit, and we want the upper limit to be n, for example. And the other thing that we need the value of x. So you may predefine the value of x if you want, or you can tell the user to input the value of x. So for example, the user can input x to be pi, which is 180. You can input the x to be pi over 4, which is 45. So we say user enter value x. Okay, so for that, user enter value x, and this value of x should be in radians. And after that, what we need is to start. What we need is to initialize sin x. So we'll say sin x is equal to 0 before we enter the for loop. We need to initialize sin x first. So sin x is equal to 0, and I'll just continue from the other side. We'll say for n is equal to 1 to the upper limit, which is this n is the one here and the one here as well. And then we'll say sin sin x is equal to sin x is equal to -1 to the power -1 to the power, okay, -1 times x -1 times x to the power 2 times n, 2 times n plus 1, close bracket, and this is supposed to be divided by 2n plus 1 factorial. So I'll put the slash here and then just continue below and say factorial 2 times n plus 1 like this. Okay, I've forgotten one thing. We're supposed to add plus sine x. So plus sine x at the end. Here we say sine x. Then we end this. We'll just say end. Okay, let me write all of this in a clean way so that you can be able to see it properly. So what we're basically saying is for n is equal to 1 to n sine x is equal sine x plus -1. I think I forgot an n. -1 to the power n times -1 to the power n times x to the power 2n 2 times n plus 1. All this divided by space divided by factorial 2 times n plus 1. Then we close the brackets. Then we say end to the full loop. Then down here we can say f of x is equal to sine x. And once we try to implement this in MATLAB, it should give us, it should basically work. What I just wanted to do is to give you an idea of what the question you sent me is talking about. So in your case, there will be some changes on how this question is to be handled, because the question you sent me had something like Vx is equal to 100 sine 60x. Now, is it v of t? Okay, it was something like this. So the changes that will be there will be that this x here will include a 60. So instead of it being as it is on top here, instead of it being x to the power 2 x to the power 2 n plus 1, it's going to be 60x to the power 2 n plus 1. And this change is also going to be implemented here. So yes, we're going to have a 60 here. Yeah, it's going to be something like this. Then at the end, because since we have got a 100 here, after we effectively implement the code, we're going to multiply sine x. Now it's not sine x, it's sine 60x with the 100 at the end. After the for loop is done, we're going to say sine 60x times 100. So I hope this helps. If it doesn't, you can still tell me, you can still inbox me. And this is This is basically just the design. If we go into implementation, there are a couple of things that are going to change in MATLAB, like what I've used here. You're not going to say user enter upper limit, and this is how you go about it in the design. But in in MATLAB, if I haven't forgotten, you're going to say uh, n is equal to, is it input? N is equal to input. Then say you say user enter the value of n, yeah, something like this. And also for x, we're going to do the same. I think you understand this part because the code that you sent me already had this part. So I hope this helps.